So if you have out some paper, as you already should, we're going to talk about electric fields and electric field lines. You could actually call these electric force fields because they show the electric force. So let's talk about what those are and how we represent them with electric field lines. So here's the textbook definition of electric field. It's a vector quantity that relates the force exerted on a test charge to the size of the charge. So what does that actually mean? Well, first off, let's look at a couple of words here. It's a vector quantity, so that means that the direction matters. And we're talking about force exerted on a test charge. So what is a test charge? Well, test charge is simply a charge of known quantity that we place next to a charge that we don't know or that we're actually testing. That's why we call it a test charge. So let's look at what this is actually referring to and how we deal with that. Let's say that I have myself a positively charged object, and this little red dot here is going to be my test charge. If I place this test charge here, and a test charge is always positive, so if I place this test charge here, right here at this spot, I know that the positive charge is going to push my test charge away. So right here at this spot, there is a force pointing that direction. And if I place my test charge here, then I'm going to get a force in this direction. And if you do that all the way around your charge, you end up with a bunch of little arrows showing that I'm going to be pushed in all directions away from my positive charge. These are what we call electric field lines. So the positive charge is going to push things away from it. So what would it look like if I had a negative charge? Well, a negative charge, again, I'm going to use my test charge. So I place my little test charge right here, and the test charge again is always positive. So if I place a positive charge right here, it's going to be attracted towards my negative charge. So I'm actually going to have a line that points towards my negative charge. And if I go all the way around my negative charge, it's going to point all the way in all directions. So no matter where I place my charge, the line's going to point towards my negative. So these electric field lines are showing the direction that a positive charge is going to move. So your field lines always point towards negative and away from positive. Now each one of these situations I've shown you so far were simply point charges. There's only one charge. What if I have more than one? Let's say I have a situation like this where I have a positive charge on the left and a negative charge on the right. What would this test charge do? If I place my test charge right here, the positive is going to push it away and the negative is going to attract it. So it's going to travel straight across. So the electric field is going to look like that. It's going to go straight across. But remember, the electric fields go out radially in a circle from your positive charge and radially inward towards the negative charge. So if I were to place my test charge right here, the positive charge is going to push it this way. But while it's being pushed this way, the negative charge is pulling it towards it. So you end up with a charge that's going to come out and it's going to curve back towards my negative. And if I place one down here on the bottom side, right here, then it's going to do the same thing. It's going to get pushed out, but it's going to curve back around towards the negative. So if I just continue that, this is what the electric field is going to look like. Now over here, it's still going to be shooting out away from the, sorry, I drew those backwards. These are going to be pointing in towards the negative, but they're coming from some distance off. And these ones over here are still going to point out away from the positive. So you're going to get a little bit of a curve there, a little bit of a curve there. The only one that's perfectly straight is the one that's directly between them. So this would be the electric field lines of two oppositely charged point charges. Okay, so what would it look like if they were not oppositely charged, if you had the same charge? Now I have two positively charged particles here, and so again, I'm going to place my test charge. If I place my test charge right here, well, let's do it on this side. If I place it on this side over here, that's easy. The positive is going to push it away and it's going to fly off that way. So my electric field line is still going to look just like it did earlier, where they point away. And from the right positive one, same thing. They're going to point away from the positive charge. But what happens if I stick my charge here? It's going to be pushed away from this charge on the left, but it's not going to come all the way to the one on the right because it's going to be pushed away from the one on the right also. So it's actually going to curve up and away. And if I place a charge here, it's going to be pushed away from the one on the right, but not to the one on the left. So it's going to be pushed up and away also. So your field lines actually end up giving you a situation where you have this space here in the middle, a little line where the charge is not going to go, and so when it comes off here, it's going to go like that, and it's going to curve and go like that, and one coming off here is going to curve like this and like that, and they're just going to get really close to that line, that dotted line that I drew, but they're not going to cross it. And this, you should be able to see then, shows you that this is why positive charges push themselves away. The electric fields push on each other. And so you end up with a situation like this, where the electric field is distributed away from the positive. Now you'll notice that the only difference, if I were to make these negative charges instead of positive charges, if they were negative instead of positive, the only difference would be the direction of these arrowheads. They would not be any different shape. They would just be pointing in instead of pointing out. That's the only difference. So that is basically all you really need to know about electric fields and electric field lines, with the exception of a couple of rules that I'm about to give you. So, rule number 1 for drawing electric field lines. We'll call them E fields. All right, E field lines always point away from positive and toward the negative. That's rule number 1. They always go away from positive and toward negative. Rule number 1. Always have to follow that. Rule number 2, for drawing electric field lines, the electric field lines cannot cross each other. That's why I drew the ones earlier where I had the 2 plus charges, where the lines come and curve, and they come and curve, but they meet up with that little line, and if you remember from math, that line would be called an asymptote, but they never cross each other. They get really, really close to each other, but they do not cross. So that is rule number 2. The lines cannot cross each other. Then, of course, the last thing that you need to be familiar with is if you have this distribution like you see here, you'll notice that as they get pushed closer together, the electric force is greater here. So the closer the lines are together, the stronger the electric force caused by the field is. So if you remember those things, then your homework shall be pretty easy for you.